Welcome to this roundtable. The mission of Apollo 11, as a milestone in human accomplishment, offers us a unique vantage point from which to scrutinize our understanding of the universe. Let us engage in a discerning examination of its impact on science and humanity. Albert, your thoughts on the philosophical ramifications of this endeavor?
Venturing to the moon transcends mere physical displacement. It epitomizes the zenith of human curiosity and collective ambition. As we reach out to touch the barren, dusty surface of our satellite, we do not just conquer a celestial body. We surmount the limitations imposed by our own doubts and fears. It is a clarion call to the intellectual spirit, reminding us that our quest for knowledge is boundless.
I find the biological implications most intriguing. One cannot help but wonder what subtleties of life we might discover or indeed introduce on such a journey. The moon, as a sterile environment, poses questions about the resilience and adaptability of life as we know it.
The preparation for Apollo 11 necessitated unparalleled scientific rigor. The meticulous study of materials capable of withstanding the harsh conditions of space was crucial. This mission did not just challenge our physical capabilities, but also our capacity for innovation and resilience in the face of the unknown.
The audacity to venture into the celestial realm parallels the courage of those who first turned their gazes upwards through the lens of a telescope. This mission signifies an extension of that very curiosity, driven by the relentless human urge to explore and understand the cosmos.
Think of the technological legacies birthed by this voyage. The innovations in computing, materials science, and communication, to name but a few. Apollo 11 is not merely a chapter in the annals of space exploration. It is a beacon lighting the path toward unfathomable future advancements.
Yet one must ponder, as we extend our reach, do we also extend our hubris? Exploration mandates responsibility. Venturing into the heavens is not just a triumph, but a solemn duty to proceed with both caution and reverence for the cosmos.
Just so, Albert. Our discourse must acknowledge the gravity of this enterprise, not merely for its engineering feats, but for its implication on the fabric of human understanding and philosophy.
And let us not ignore the tremendous leap in observational technology this mission represents. From telescopes to spacecraft, each step forward is a stride towards demystifying the cosmos.
While the technological triumph is undeniable, the biological ramifications must not be overlooked. The effects of such travel on the human body and the potential discovery or contamination of extraterrestrial ecosystems present profound ethical quandaries.
Indeed, Charles. But let us also celebrate the indomitable human spirit that conceptualizes and realizes such quests. It is in these moments of triumph that humanity's potential shines brightest.
This discussion lays a strong foundation for our exploration today. As we proceed, let our deliberations be guided by a commitment to uncovering truth, advancing human knowledge, and embracing the unknown with an open mind and heart. Let us delve into the realm of technological marvels, beginning with the Apollo guidance computer. Nikola, I believe you have insights on the innovative engineering that powered this device.
Indeed, Isaac. The Apollo guidance computer was a feat of electrical engineering, embodying theories far ahead of its time. Utilizing the principles of binary code and rudimentary computing, it was nothing short of revolutionary. It pains me, however, to observe that in my time, I could only dream of such computational prowess.
While Nikola marvels at the engineering, let us not overlook the computational challenges involved. The very fabric of space and time, which I've spent my life unraveling, posed a unique challenge for navigating to the moon. This endeavor required an understanding of relativity, a concept not fully accepted in my era.
Your point is well taken, Albert. The mathematical precision needed to calculate the lunar trajectory indeed demanded a comprehensive grasp of motion and force, areas I have dabbled in. However, this computer's ability to perform such calculations in real is beyond even my most ambitious dreams.
And let us not forget the materials and radiation challenges in designing such a computer. The device had to withstand the harsh conditions of space, a concern largely absent in your terrestrial observations, Isaac. My research into radioactivity could have predicted the deleterious effects of cosmic rays on the computer's components.
Astonishing as this guidance system is, we must acknowledge the lineage of discovery that led to its creation. The astronomical tools I developed laid the groundwork for understanding celestial movements. To compare my humble telescope to this computer is to marvel at the exponential leap in technology and ambition.
Galileo, while your contributions are indeed foundational, the leap in technology you admire was made possible by embracing the electrical currents I so dearly championed. It is electrical engineering that breathed life into this computer, giving it the ability to navigate the cosmos.
Yet, all this technological bravado would be for naught without the underlying theories of physics, including my own on relativity. It is the theoretical framework that allows us to even conceive of navigating space-time.
True, but without an understanding of the materials that can withstand space's harsh environment, theory remains just that. My work, and that of my successors in radiation research, made it possible to shield and protect the Apollo guidance computer.
A riveting discussion, indeed. It is clear that the creation of the Apollo guidance computer was a convergence of many fields: physics, engineering, materials science, and mathematics. Its existence and successful operation are a testament to human ingenuity and the collaborative spirit of scientific exploration.
Let us not forget, though, that the real achievement lies not just in engineering prowess or scientific theory, but in the audacity to imagine and then reach worlds beyond our own.
A fitting conclusion to our discussion on the technological innovations behind the Apollo guidance computer. The ingenuity and collaborative effort behind this marvel have indeed expanded the boundaries of human achievement.
The very essence of space exploration demands miniature marvels. Without the profound reduction in size of technological components, the journey to the moon would have remained a mere fantasy.
Indeed, Albert. The advancement in chemical processing and material science was crucial. Miniaturization isn't just about making things smaller, it's about making them work more efficiently at a reduced scale.
Both of you are correct, but let's not overlook the electrical engineering achievements. The transistor, for example, revolutionized every aspect of the Apollo 11 mission's technology, enabling more complex circuits to occupy less space than ever before.
In my time, had we the capability to miniaturize, the telescopes I pointed at the skies would have been mightily more powerful. Instead, we made do with the cumbersome and the gigantic. It's miraculous how far you can go when you reduce the size, yet increase the capability.
The mathematical elegance behind miniaturization cannot be overstated. Efficiency in systems, both natural and man-made, often follows geometrical principles that favor smaller, optimized formations.
However, one must ponder the implications of this relentless pursuit of the smaller. As we condense matter and energy, the universe's fundamental laws become more prominent, sometimes presenting theoretical and practical challenges.
One must indeed mull over the ultimate boundaries of miniaturization. Yet I believe that our capacity for invention is only limited by our imagination. The challenges you speak of, Albert, are but stepping stones.
Challenges, yes, but also opportunities. The radiation shielding techniques we developed for space travel were born of the necessity to protect miniaturized, sensitive components. This has applications far beyond space, in medicine and industry.
It's fascinating, yet I can't help but wonder at the simplicity of it all. In my era, we sought to magnify, to enlarge the heavens to our eyes. Now you seek to compress the essence of Earth's might into the palm of your hand.
Miniaturization has certainly enabled us to reach beyond the bounds of Earth. But let us heed the words of caution. In our quest to make things smaller, let us not lose sight of the universe's vast, unexplored expanse. The balance between the infinitely small and the infinitely large is where true discovery lies. Let us then move to the heart of lunar exploration, the geological implications of samples collected by Apollo 11. Charles, you've spent a lifetime studying the evolution of species on Earth. What significance do you find in these lunar samples? The lunar samples present an immaculate archive, free from the Earth's relentless geological processes. They offer us a lens into the solar system's history, perhaps hinting at Earth's early visage before life emerged. However, Nikola, I must assert, without biological nuance, these rocks, while fascinating, are but sterile witnesses to the cosmos's dance.
Ah, but Charles, you underestimate the power of lifeless matter. These lunar samples hold the secret to energy sources we can only begin to fathom. Consider, for instance, the potential of harnessing helium-3 for nuclear fusion. The moon, thus, may not teem with biological life, but could be crucial for sustaining it back on Earth.
I must interject here. These samples, beyond their geological and potential energy significance, are invaluable for understanding cosmic radiation's effects on materials. This understanding is crucial for the safety of future missions, not to mention radiation's role in the universe at large.
Interesting points, all. However, the greatest value of these samples lies in what they tell us about the universe's grandest scheme. Our theories of the moon's formation, if it indeed was birthed from Earth or through some cosmic collision, impacts profoundly our understanding of gravitational forces and the dynamic ballet of celestial bodies.
While your modern theories intrigue me, I can't help but feel a connection to these lunar rocks. With my telescope, I unveiled the moon's mountains and craters. Yet now, you hold pieces of it in your hands. This tangible piece of the heavens marks a new era of discovery, not unlike what I commenced with my observations.
Indeed, Galileo, and imagine the energy we could harness from these pieces. The path to understanding the universe also lights the way to a future of boundless energy.
Energy or not, I assert again, the biological conversation around lunar samples is moot. There's beauty in the lifeless, yes, but the thrum of life, the evolution on our own planet, is unmatched.
While I share Charles's fascination with life in the domain of scientific exploration, every atom in those samples, whether part of a living entity or not, contributes to the grand tale of the cosmos.
Quite true, Marie. Whether it concerns living beings or inert rocks, every scrap of matter has its narrative, its part in the infinite equations that describe our universe.
So it seems, our lunar detritus, as unassuming as it may seem, holds keys to myriad domains, from the birth of celestial bodies, potential future energy sources, to the effects of cosmic radiation. These silent stones do indeed speak volumes. Let us proceed then, keeping in mind the valiant narratives spun by these cosmic travelers. Let us delve into the mechanics of the lunar orbit rendezvous, a pivotal aspect of Apollo 11's mission architecture. The elegance of celestial mechanics was once thought to be governed by immutable laws I laid down. Yet, the application in this context was a leap beyond my terrestrial considerations.
Indeed, Isaac. But your laws of motion provided a solid foundation. However, the concept of relativistic effects, which I introduced, plays a role in understanding the trajectory of objects moving at such high velocities in the vicinity of massive bodies like Earth. The precision required for Apollo 11's journey cannot overlook these subtleties.
I must interject. My telescopic observations of the moon's surface centuries ago provided the initial curiosity and wonder about our satellite. To think that now, mankind has not only observed, but touched its surface by navigating the heavens with such precision. The mathematics involved must indeed be complex, but the underlying principles remain those observed through my humble telescope.
Galileo, your observations were indeed groundbreaking, but let us not forget the role of electromagnetic fields in space travel. Although not directly involved in trajectory planning, the understanding of these fields is crucial for space systems functionality. My work on alternating currents and electromagnetic fields opens doors to considerations beyond mere physical motion. Energy transfer, communication, even navigation could be influenced.
While your contributions to electromagnetism are notable, Nikola, they divert from the core of celestial mechanics. The challenge was to calculate a trajectory that would allow for a moon landing and return using the minimal amount of fuel, an optimization problem of a highly practical nature.
And let us not overlook the role of radiation encountered en route. My research into radioactivity has profound implications for understanding the space environment. Protection from cosmic and solar radiation was critical for the safety of the astronauts, affecting both the trajectory and timing of the mission.
Marie brings a pertinent aspect to our discussion. The holistic view of space travel entails not just the accuracy of the trajectory, but also ensuring the safety of humans venturing into this unknown. It's the marriage of theoretical physics with practical, life-preserving engineering, a task that requires ingenuity beyond mere calculations.
Your point is well received, Albert. However, the practical application of our collective theoretical work, mine in mechanics, yours in relativity, and Marie's in radiation, demonstrates the intertwined nature of scientific disciplines. Apollo 11's mission planning and execution were a testament to human ingenuity in applying these principles.
While we ponder the practicalities of human survival and navigation in space, let us not lose sight of the sheer audacity of this endeavor. To leave Earth, to navigate to our celestial neighbor, and to return safely, this is a dream realized, a testament to human curiosity and determination. The mechanics and the physics, while complex, serve this greater purpose.
As we discuss the trajectories and mechanics, I dream of future explorations energized by my visions of wireless energy transfer, providing power to distant space travelers. The journey to the moon is but a first step in the grand adventure awaiting humanity among the stars.
Each of your contributions to science plays a role in the grand scheme of space exploration. Our discussion on trajectory planning and lunar orbit rendezvous reflects the culmination of centuries of scientific thought and discovery. Apollo 11, in its essence, was a mission bound by the laws of physics, yet driven by the boundless aspirations of humanity. Let us delve into the design and effectiveness of the lunar module's life support systems. The conservation of energy within these closed systems is a paramount concern. Marie, your expertise in radioactivity and chemistry must provide an interesting perspective on the matter.
Indeed, Isaac. The life support system's functionality hinged on understanding the chemical and physical processes at play. Ensuring breathable air, potable water, and manageable waste systems were critical. My work with radioactive elements reveals the importance of shielding and containment, equally vital within the lunar module to protect the astronauts from harmful radiation.
Fascinating, Marie. Yet I imagine with the advancements in technology, we could envisage life support systems powered by alternative energy sources. My studies on alternating currents and wireless energy transmission could have significantly improved the energy efficiency and safety of these systems.
While your visions hold merit, Nikola, it's essential to consider the environment these systems are designed for. The vacuum of space, the lack of an atmosphere, and the reduced gravity present unique challenges. Creating a mini-Earth within the module is a philosophical endeavor as much as a scientific one. It poses questions about our adaptability and resilience.
Adapting to new environments is indeed fascinating. From a biological standpoint, the necessities for human survival, air, water, food, and warmth, remain unchanged, whether on Earth or in space. The module's life support system is an encapsulated demonstration of evolution's fundamental principles, albeit technologically induced.
Aye, but let us not forget the courage it takes to entrust one's life to these systems. In my time, challenging the unknown often meant facing the Inquisition. The concept of leaving Earth's embrace to touch the moon's surface would have been unfathomable. Yet, here we stand, discussing such a reality. The advancements in observational technology I pioneered now pale in comparison.
While your contributions laid the groundwork, Galileo, the complexity of modern scientific endeavors, like the lunar module's life support, requires interdisciplinary knowledge. It's not solely about observation, but also about understanding and manipulating the environment to sustain life in the most inhospitable conditions imaginable.
Indeed, Marie. Yet think of the future possibilities. Systems that not only support life, but recycle and regenerate it indefinitely. We've only scratched the surface. My visions of a wireless world extend to creating environments where energy is as abundant in space as it is here on Earth.
Imagination will certainly fuel future advancements, Nikola, but our grounding in reality, in the tangible experiments and theories, must guide us. The balance between what is theoretically possible and what is practically applicable defines our progress.
Thus, the dialogue between our understanding of physics, chemistry, biology, and technology shapes the evolution of life support systems. The endeavor of Apollo 11 was but a step in humanity's journey, with each of you contributing a verse to this ongoing epic of exploration and discovery. Let us direct our discourse to the realm of microgravity and its effects on human physiology during the monumental Apollo 11 mission. The alteration from Earth's gravity to the Moon's lesser pull poses questions most intriguing to the natural philosophy and mechanics underlying our bodily functions. Indeed, the biological adaptations to such an unnatural environment are paramount. My studies on the finches of the Galapagos Islands revealed how slight changes in an environment can significantly influence the course of evolution. Transposing such drastic changes as microgravity on the human body leads me to ponder the potential long-term evolutionary impacts should humanity choose to inhabit worlds beyond our own.
There's also the concern of radiation exposure in space, vastly different from that on Earth's surface. My research into radioactivity has shown the deleterious effects it can have on cellular structures. In the void beyond Earth's magnetic field, these effects are magnified, posing a substantial threat to astronaut health over prolonged durations.
Speculating on technological solutions, it's conceivable to imagine creating artificial gravity through rotational motion of spacecraft, drawing upon principles I applied in alternating current systems. Undoubtedly, mitigating microgravity's effects through such means could lead to profound advancements in space habitation.
Your point, Nikola, dances around a fundamental curiosity of mine, the theoretical understanding of gravity itself, this invisible force that binds the universe, yet eludes a full grasp within our unified field theory. The effects of its absence on the human body are as much a riddle as gravity's nature. This riddle extends to the very curvature of space-time these astronauts traveled through, distorting not just their physical selves, but perhaps, in ways we yet grasp, their intrinsic nature.
And yet, the conservation of motion in such an environment provides a unique lens through which to view my laws. The manner in which an astronaut's limbs continue in motion until acted upon by another force inside the spacecraft offers practical demonstration of principles previously confined to theoretical musings and terrestrial experiments. Interrupting the flow, but must we not consider how such an unnatural state might affect one's mental faculties? The psychological implications are vast, and I dare say, could impact one's evolutionary fitness in such environments.
A valid concern, Charles. It's clear the intersection of physics, biology, and psychology in microgravity presents a complex web of challenges and inquiries. Our collective research spans these realms, each providing a puzzle piece towards understanding and overcoming the myriad effects of space travel on the human constitution.
While the immediate solutions elude us, the pursuit of such knowledge is what propels humanity forward, an electric current of curiosity that drives our species to greater heights.
A sentiment I echo, Nikola. The quest to understand these mysteries, be they through physics, biology, or engineering, unifies our seemingly disparate sciences. And in this unity, perhaps lies our greatest strength against the vast unknown. The psychological impact of seeing Earth from space, how must it transform one's perspective? Imagine the overview effect, a cognitive shift in awareness about our planet. It's a hypothesis begging for exploration. I wager it's akin to the relativity of our place in the universe, small yet profoundly interconnected.
I wonder about the isolation. On the Beagle, I was enveloped by Earth's most remote places, yet always under its sky. The astronauts, however, were apart from Earth, floating in an unfathomable solitude. The psychological ramifications of such isolation on the human psyche must be profound.
The conversation veers towards the abstract, yet let us not overlook the tangible. Radiation in space, a silent but ever-present threat. How does it affect them, biologically and mentally? This invisible force, capable of altering the very fabric of our being, must weigh heavily on their minds.
Space's psychological challenge, fascinating indeed. Yet consider the technological solutions at our disposal. Wireless transmissions could bring comfort, a connection to Earth despite the vast emptiness. But my concepts were often deemed too fantastical. If only my visions of wireless energy and information were realized, we might mitigate some of these adversities.
There's resilience in the human spirit, tested against the unknown. My telescopic observations expanded humanity's understanding of the cosmos, yet I faced the Inquisition's wrath for challenging the status quo. The astronauts, too, confronted the unknown, but how did this extreme shift in perspective challenge their mental fortitude?
Resilience, Galileo, is key. Yet what fascinates me is the psychological concept of unity, seeing Earth without borders, a whole, indivisible entity. It's a profound realization that could foster peace were it embraced universally.
Indeed, Albert, if humanity could universally embrace this cosmic perspective, what leaps in energy sustainability, world peace, and scientific exploration we could achieve. My wireless energy transmission wasn't just about electricity. It was about binding the world in unity.
Unity and peace are noble, but the primal instinct for survival and dominance lingers in us. Witnessing Earth from afar might highlight our shared vulnerabilities and common fate, potentially catalyzing a shift towards cooperation. Or so one might hope.
Cooperation, yes, but let's also speak of resilience in the face of profound adversity. Radiation, isolation, the unknown. Facing these hazards requires not just technological solutions, but inner strength. How the mind adapts, learns, and overcomes, it's a testament to human ingenuity and spirit.
Indeed, Marie, and let us not forget, every challenge surmounted in space, every fear overcome, adds to our collective knowledge. It propels humanity forward toward greater discoveries. The unknown, once conquered, becomes a beacon of knowledge for all mankind.
And yet, we've only begun to scratch the surface of understanding the psychological effects of space travel. As we venture further, the need for both rigorous scientific study and profound philosophical contemplation becomes ever more clear. The journey of Apollo 11, while monumental, is but a single step towards the infinite expanse of the unknown.
Precisely, Isaac. It's this intersection of science and philosophy that will pave the way forward. The unity of Earth seen from space is not just a psychological phenomenon, but a call to action, a challenge to our preconceived notions of self and other, a dare to dream of a better, united future.
Let us delve into the complexities of space-to-Earth communication, a feat as pivotal as the celestial mechanics that ferry us to the stars. Nikola, your insights on the technological marvels behind this?
Indeed, Isaac. The crafting of a communication system capable of breaching the vast silence of space is akin to capturing lightning in a bottle. We harnessed electromagnetic waves, invisible yet potent messengers, spanning the void at the speed of light. A symphony of electrical engineering and daring innovation.
While the elegance of electromagnetic theory cannot be understated, the practical challenges, radiation, material durability, and the harshness of space, posed significant hurdles. Success lay not merely in theoretical brilliance, but in overcoming the physical degradation of signals over incomprehensible distances.
In my time, observing the heavens was a dialogue carried only by the eye, interacting with the celestial through the lens of a telescope. This communication, wrought by technology, is an extension of those observations, a literal conversation with the cosmos, though the medium has evolved from glass to the ethereal whispers of radio waves.
Yet, consider the relativistic impacts on these transmissions. Signals, as they journey across the gravitational wells of celestial bodies, are subject to time dilation, a profound reminder of the interconnectedness of space, time, and velocity, a ballet of physics that ensures no message is truly instantaneous.
A remarkable point, Albert. The choreography of universal laws governing even the simplest transmission is a humbling reminder of our place in the cosmos.
Simplicity is deceptive, Isaac. The act of communication across space is a testament to human ingenuity, overcoming barriers that once seemed insurmountable.
And let us not overlook the materials, the choice of which determines the fidelity of our celestial whisperings. Radiation-hardened electronics, developed through meticulous experimentation, safeguard our lines of communication against the indiscriminate fury of solar radiation.
There's a poetic symmetry to it. In my day, we relied on the positions of stars to navigate the seas. Now stars aid in navigating the ether, guiding our messages home.
It brings to light the indomitable nature of curiosity. Each message sent, each signal received, is a sonnet to our unyielding quest for understanding, defying distance and the void's silence.
A sonnet, indeed, but let us not romanticize without acknowledging the engineering prowess that permits such poetry to exist. It is a bridge constructed with the iron of theory and the concrete of practical application.
A bridge, you say, Nikola. A fitting metaphor for the act of communication itself, a construct that enables us to traverse the otherwise insurmountable. The dialogue between Earth and the heavens, once a dream, now a reality made possible by minds such as ours around this table.
Yet we must proceed with caution and respect. The cosmos does not forgive arrogance lightly. Our foray into the heavens is only just beginning, and each step, each message, must be crafted with the precision of a scientist and the awe of a poet.
The awe of a poet, indeed, Marie. As we cast our messages into the vast unknown, let us remember that we are not just scientists, but also stewards of this grand endeavor. Our communications, a testament to the indelible human spirit yearning for the stars.
Let us now turn our contemplation to the matter of international space law, a territory as vast and uncharted as space itself at the times of our earthly lives.
Ethically speaking, the very concept of claiming territory beyond Earth calls into question the essence of our morality. Surely, the universe, in all its grandeur, does not belong to one nation, one people. Imagination encircles the world, I've often said. Should not this principle guide our steps beyond Earth?
But here's the rub. In the pursuit of science, territories have always been claimed in the name of discovery. Is not the act of planting a flag an extension of a natural observation, a way to mark the understanding of new lands, albeit now celestial?
I cannot help but agree with Albert. The dangerous allure of claiming space territories can eclipse the collaborative spirit of scientific discovery. Our endeavors to the stars should elevate humanity, not divide it. Knowledge, like radium, is not to be hoarded and hidden away, but shared for the progress of all mankind.
But you speak of ideals. Remember, even the telescope, once a tool for celestial understanding, was used for naval warfare. Can we not foresee that the rush for space might be driven by similar terrestrial conflicts, guided by the desire for supremacy rather than the collective pursuit of knowledge?
Alas, the distribution of celestial territories may indeed lead to conflict. However, let us not forget the potential for technological advancements that could come from this competition. The energy of the cosmos is vast. If we as a species can harness it, the need for terrestrial squabbles over land and resources might diminish.
Gravity binds us not only to Earth, but also to our basest inclinations. What, then, is the solution? Shall we abandon the quest for space in fear of our own shadows, or shall we step forth, enlightened by the lamp of knowledge, to legislate a new era of exploration?
True enlightenment lies in partnership, not domination. An international treaty rooted in peace and scientific endeavor may serve not as shackles, but as the very wings to lift humanity higher.
Yet, evolution teaches us that competition drives the species forward. Can we, in good conscience, stifle this inherent impulse, even for the greater good?
The radiation of space knows no nationality. It cares not for borders. Our safety measures, our research should be shared. Collaboration in space could be the catalyst for peace on Earth, an antidote to the poison of division.
One must only look to the stars to see the dance of celestial bodies, governed by laws, but free from the pettiness of terrestrial disputes. Might we learn from the heavens a way to coexist, to explore without the tyranny of possession?
Visions of the future must be built on the solid foundation of unity and mutual respect. Let us harness the collective genius of humanity, not for conquest, but for the uninterrupted progress of civilization.
Let us turn our gaze now to the legacy of Apollo 11, foreseeing the paths it might pave for future space exploration endeavors. Thoughts?
Apollo 11 blasted through Earth's atmosphere, not just escaping the gravitational shackles, but also the fetters of narrow imagination. This journey allied with my visions of energy transmission across the cosmos, envisioning future societies thriving beyond Earth. Yet we must cautiously harness these energies, lest they lead us to our own downfall.
Indeed, Nikola. The radioactive elements I discovered have dual potentials for harm and benefit, reflective of space exploration itself. Apollo 11's legacy teaches us the importance of scientific rigor and ethical consideration, ensuring our explorations contribute positively to humanity rather than leading us into peril.
But let us not forget the crucial role of observation and curiosity that has always driven our kind to look beyond. My telescope revealed the moons of Jupiter, expanding our understanding of the cosmos. Apollo 11's journey is but a continuation of this eternal quest for knowledge, aspiring to uncover the secrets that lie beyond our moon and further still.
Yet, as we extend our reach into the unknown, we must also contemplate the evolutionary implications of such endeavors. Apollo 11 symbolizes a pivotal moment in human evolution, not merely in a physical sense, but in our capacity for innovation and exploration. It beckons us to consider how we might adapt, biologically and socially, to life beyond Earth.
You speak of evolution, Charles, and innovation, Nikola, but let us not overlook the ethical dimensions of space exploration. Apollo 11 has indeed opened a gateway to the stars, but it also imposes upon us a grave responsibility to pursue cosmic harmony rather than celestial conquest. It exemplifies the quest for understanding, urging us to transcend our conflicts and unite in our quest for knowledge.
An invigorating discussion, indeed. The legacy of Apollo 11 encompasses not just the technological feats achieved, but also the philosophical, ethical, and evolutionary considerations it provokes. It is a testament to humanity's relentless quest for knowledge and our unyielding desire to explore the uncharted territories of the cosmos. Let us continue to question, to explore, and to strive for a deeper understanding of the universe. Let us conclude, not with an ending, but with a vision forward, spurred by the monumental leap that is Apollo 11. How does this journey into the cosmos alter our understanding and aspirations?
The profundity of Apollo 11 lies not merely in the physical traversing of space, but in the conceptual leap for mankind. It's as if we've looked into nature's mirror and seen not just our reflection, but the universe staring back, urging us to understand its laws on a grander scale. It forces us to reckon with the relative nature of time and space and to embrace the cosmic perspective that we are but a speck in the vast universe.
Apollo 11's legacy intensifies the importance of rigorous scientific inquiry and interdisciplinarity. My work with radioactivity, once thought esoteric, found its place in cosmic explorations. This mission exemplifies how interconnected our scientific endeavors are, from understanding the atom to walking on the moon. It impels us to push the boundaries of our knowledge and technology collectively.
Reflecting on Apollo 11, one cannot help but dream of future technologies inspired by such a mission. Electromagnetic fields and wireless transmissions, which I have dedicated my life to understanding and shaping, are the keystones of future space travel and communication. This mission is but the infancy of humanity's technological evolution towards harnessing the cosmos.
From a biological standpoint, this mission extends the canvas of evolution further than we ever imagined. It provokes questions about life's resilience and adaptability in extraterrestrial environments. The moon's barren landscape, though seemingly inhospitable, opens conjectures on life's potential beyond Earth. It's a call to expand our evolutionary perspectives to a cosmic scale.
Through my telescope, I saw a universe that was vast and boundless, yet Apollo 11 has shown that it is within our reach. It challenges my observations, pushing the boundary of what is knowable and navigable. This mission does not just expand our world, it propels our very understanding of the cosmos into new realms of possibility.
As we've navigated through our discussion, one thread is clear. Apollo 11 serves not as a pinnacle of achievement, but as a beacon, illuminating the endless frontier of the unknown. It is a testament to human curiosity and resolve, reflecting not where we have been, but where we dare to go.
In the spirit of exploration, let us then not see space as a realm to conquer, but as a mystery to unravel. United in our quest for knowledge, may we forge ahead, not as separate nations fueled by competition, but as a species driven by a shared wonder and a collective ambition for peace.
This, our concluding observation, is but a prelude to the next chapter of human endeavor in the cosmos. As we stand on the shoulders of giants, we look to the future, not with trepidation, but with an insatiable thirst for the wonders it holds. Let us step forward, guided by the light of reason and the indomitable human spirit, to chart the uncharted, understand the misunderstood, and dream the undreamed.